And welcome everybody to Globebusters Flat Earth Endgame. I am your host, Bob Xanadude60, and we are back with another great show for you today.
Same date that it changes in different countries.
Yeah, weird. Okay, I'll message you. That's probably what's going on.
Yep. No, we pretty much have kept the same hours for the last 4 years, every Sunday at noon Pacific, and whatever the time change goes with that, that's cool. All right, so let's introduce our very esteemed guest. These two gentlemen have been on Globebusters one time before, and they are definitely some of my favorite content producers out there. Steve and Ross have come forward with several really good series. I particularly love the NASA fanboy questions that you guys do. That's one of my favorite series for sure. And recently, you have been doing the Comets Cataclysms series, which just finally culminated in Part 6C, which was absolutely fabulous. Talking about Earth cycles and natural disasters and reset events and stuff like that. And again, it's not done in the spirit of fear mongering. This is simply taking documented facts and historical things and kind of shining a little bit of a light on it. But most recently,
because you're flat Earth, I just wanted to ask you guys about the dome. Do you all believe in the dome?
I do, but
Yeah,
I don't
I
think
think so.
everybody does, but I certainly do.
Well, whoever does, what do you guys think is up there? What is it?
I go ahead, Uru. Or
No. My
Rodrigo.
answer is
Yeah.
very short. I give a super tiny presentation on the Dallas conference, but for all I research, we have like a natural process. Getting colder when you go up there, very cold, almost 0 Kelvin degrees. And 0 Kelvin, not degrees, 0 Kelvin. So when you start getting lower temperature on the gas itself is going to start to crystallize. So for me, the symbolic behind the dome is just like a crystallization on gases, and that's for wrapping around. I don't want to extend in the answer, but for me, it's a natural process of gas being crystallized for the lower temperatures that you reach when you go up there.
And did you see my last film, Euro? I'm not sure if you've seen Comet 6C.
No, I downloaded, and in fact, we have a Spanish YouTube channel that are translating all your material. So I need to see the last one.
Nice. Okay. Well, okay. So you haven't seen it. So
It's
because
playing
that's
right
what
now.
I wanted to ask. Do you think it's the sun is whatever the sun is, whether it's a projection or whatever, or a thing, is that why? Do you think there's waters above and they're frozen because they're farther away from the sun? Is that what you...
No, exactly. They are far away from the sun because we don't know the nature itself of that. This is my opinion, of course, but we don't know exactly what the sun is and how it produce his magic. You go to Eric Dollar, for example, research, or you can go to the people that said it's a transformer or blah blah blah. But the thing is that the only thing that we can do is make theories, because nobody going to reach and see what are the behavior in that particular part of the sky. Nobody get out there. So
Only
the
NASA,
only thing,
they claim.
yeah, only NASA, exactly. So I don't know how the things. I don't know if we have water above or not. If we are like some kind of experiment for other beings. But the thing is that the only thing that I really called my attention was this sounding rocket launched from the same company that was launched the fast rocket, the Go Fast rocket. They has been contracted by NASA, and they send now they call Up Aerospace. That is the name of the company, and they send a rocket. And when you see the telemetry that the rocket are collecting through the flight, when the rocket reach the 120 kilometers, the outside temperature is almost 0 Kelvin degrees. So that is very strange, because it's something like minus 269 Celsius degrees. And
Almost absolute zero.
That's
Yeah.
Exactly. You can start thinking, well, what is the kind of thermometer that these guys have to make this measurement, whatever. The fact is, if you go right now to the official webpage of these companies, the videos is still uploaded and you still can see those measurements. And if you combine that with what is called superfluids, you have all the condiments, all the parts, ingredients. Thank you. All the ingredients to start making this hypothesis where, well, if you have a gas and we have this and this is official, we up in the atmosphere we have the hexafluoride, which is a gas 6 times more dense than the air, and when you start freezing that gas, it became a crystal. So if you start to make if you start to thinking, okay, if to 120 kilometers we have this temperature, what happens if we go more high? Maybe it's more cold, and it could be this gradient where it starts going so low in temperature that the on gas start to crystallize and form like a dome, but
Yeah,
not like a artificial dome made by someone else, but nature dome.
It could be sky ice, right?
If you watch the movie that's running right now, it just said all that.
It's talking about that.
We're having a chuckle. What about the great deep?
Nice.
Why then wouldn't the waters below be frozen? Why? How could there be? What's heating the waters below then, if that exists?
They're highly salinated, the waters below.
Yeah,
that's part of it. And also, guys, remember what some of the leaked information that's come out about Antarctica, right? Is it's a very, very strange kind of ice that they're talking about.
Blue ice.
They actually call it sky ice, right?
Yeah, I remember that.
So
right. Yeah.
Yeah, so you could be right.
Yeah, potassium chloride. Yeah, liquefied air from potassium chloride. One possibility. Jaron, what about you, man? What's your dome take?
I kind of agree with what Euro says. I mean, I'm in the same boat that until I see evidence of there being an actual physical barrier there, do I think that there can be a barrier made of something else? Sure. So I'm not sold either way, open to either one.
Yeah, I got more interested about the meteor pieces falling down. Like if they were coming, because if this is a machine, that's just outrageous.
Right.
But that's what, but you all agree there's something there. Whether it's electromagnetic or we're in a pressure. It has to be something.
For me, the one thing that's really interesting for everyone, I think, here as well is the sprites, right? Because we see them, they seem to be coming off of something. They seem to be holding on to something. And also one thing that to add to what Iru has said, when that rocket, when we watched this Globebusters before, when the rocket enters that superfluid area and that temperature, it starts acting in a different way, right? The physics.
Are you talking about the SpaceX thing? Is that the rocket you're talking about?
No. It's sounding rockets, the go fast rockets. If you like to bring it up,
I can show you if you want. But
if they want.
Can you show us? Do you have clips of that? I've never seen. We haven't seen it, so we don't know what you're talking about.
Yeah. What happens is this: like it starts once it gets to this threshold. When it gets super cold, it seems to enter some sort of other state, and they cut it. They don't let you see everything. And what happens? They only show you when it almost before it starts to come off this area where things are different. The physics seems to be different, and because of the superfluids, as Iru explained.
No, and also the other nice thing is how the rocket passing certain point is self-oriented again.
That's what's weird, and that's weird. And the sounding rockets happen.
What do you mean it's self-oriented? What do you mean?
Iru, go ahead and bring it up, and I will present you.
Okay.
Yeah, please.
You guys are going to dig this, Ross and Steve. This when Eero presented this at FEIC in Dallas, it just blew my mind.
Yeah, there is not the full. I have like 20 more parts that I didn't have the time to organize, but the main thing behind this hypothesis, it's here. So if you want to Let me just, okay, when you want to, I can present it.
You are presenting.
Yeah, now. Right
Okay.
now.
Okay.
We are definitely intrigued.
And remember that the electrical universe and the team behind the electrical universe, they also are behind the electrical phenomena to explain some kind of volcano eruptions and earthquake. And they do these experiments when they charge in this chart. They are charging the ground, and like you see, it's not only affect the part of the where they receive the charge, but also there start underground. There are happening all this kind of electrical connection, producing like secondary effects on the ground. And I just showed this because I have in my slider. But when you go from outside, you can see at the same time they are receiving electrical discharge in this area. It's also happening underground. So, like you mentioned before, I mean, these kind of phenomena are related and connected with some kind of electrical behavior in our nature. At least that's my opinion.
Well, we were talking about this the other day because, there's lava popping up from underground. But, like Ross was saying, when you want to dig a freezer in the ground, what is it, 6 feet?
Over here, it's 90 centimeters.
Yeah, what does it explain it? Like the ground, what do you call it?
The permafrost.
The permafrost,
past the permafrost. So if you're building over here in Denmark, you have to go down 90 centimeters. That's so you're underneath the permafrost.
Yeah.
So the frost will never get down there.
Yeah, why is it warm down there? And
it's a constant 6 degrees. That's the thing. No matter how deep you go, it's a constant 6 degrees. It doesn't change.
You know what I mean? This is weird because when you get into hollow earth and all that, they claim there's a second sun down there, or even the ballers say there's a molten core of something there somehow burning. But it is true. It's warm underneath us. And it's, and why?
I wouldn't say it's warm,
no,
but it's
warm.
Constant.
But why isn't it frozen? Yeah, but why wouldn't it just get colder and colder the further you get away from the sun?
Yeah.
Have you guys ever thought about what's going on? Where's this electricity coming from down there?
That's too much for me, at least.
Well, if it's an artificial construct, like most of us believe that it has to be, and not only that, another thing I think that gives credence to the idea that there's a dome around us is the air pressure, right? Can't have air pressure without a container, right? And gravity is not going to cut it. I'm sorry. So that tells me that we've got to be contained on all sides, and it is not unreasonable then to think and just look at the evidence that shows that this is an electrical construct on all sides, no matter how you look at it. Too. And below, absolutely. Yeah. So, Mark Sargent was not entirely off when, when he's talking about this little snow globe world. I mean, however you want to look at it, it's a construct. It seems to be surrounded on all sides, and it absolutely has charge potential all around us. So, what more do you need?
Also, there's another thing that pressure can create heat. So higher pressures, there's one of the points that some geologists or flat Earth geologists have made as well as to why certain areas in the bottom, as you dig deep, could be hot. But also you have, remember, the different kinds of deposits of gas and oil and other things that it's not necessarily homogeneous. So it's hard to know, they present us with a diagram that's so homogeneous and ridiculous with the core. And there's really no differentiation. So, and then the actual geological maps, they're actually mapped on flat kind of models, which is the hilarity of it. And the knowledge from all this is buried in the industry, which is, the petrol mining industries. And they're, it's not like they're open about their research.
What about lava? We were talking about the oil would be, I don't know if there really are plates, tectonic sliding, but you need a lubricant. And Ross was checking out, he was on Google and Earth, whatever. He was looking at where all these earthquakes were kicking off because he's been following that. And they are mining oil right along what they tell us are the fault line, the plate lines. So we're like, is the oil the
Hundreds of
lubricant
thousands.
for these
It
faults?
could be, because something has got to be restoring it. Something is replenishing that oil. I mean, you would have thought that we would have used it all up long ago, and yet it just keeps coming back. So
But it's all these oil rigs are right down these fault lines. They aren't in. They're right there when you start looking. You go, what the hell?
Some people
But where's
claim it's
the
made
lava
by
coming from?
bacteria, right? They say that some of the oil is made by bacteria. Some people claim, and it's nothing to do with that idea of vegetables or dinosaurs being crushed or whatever the heck.
The Rockefellers made that one up.
Yeah.
They made that up, that fossil fuel crap, so they could charge. They have to raise the prices. The only way you can do that is to say it's limited.
So,
you
so
can't
guys,
raise the price.
let's go ahead and let Iru do this, because we're over our 3 hours already, and so we're gonna have to start wrapping this up pretty soon. Oh, no problem. This has been a great talk, and I'm digging it. But yeah, you guys are gonna love this. So Iru, go ahead and fire away, man.
Okay, I'm gonna try to do the most organized presentation. This is the video. It's an official selection from GoPro, our friends of the curvature.
Mark.
So this is the
seconds.
video. You are hearing the sound?
Auxiliary enable, signal return.
Yep, we hear it.
Okay, so I'm gonna play it. And take a look down here where
-15.
they put the telemetry.
+5. +10. Burn out. Good burn. Copy, good burn.
So the outside temperature is really going down. You have the Fahrenheit down here and the Celsius degrees. And this is, and again, this is my interpretation of what they presented here, but it's -454 degrees. Maybe I'm interpreting something, I don't know, wrong about this. But when I see this telemetry down here, I say, well, we have this kind of strange temperature that when we go up, it's not getting more hot, it's getting more cold. And in fact, when you go to the official thermosphere type of chart, thermosphere, supposedly they have this, like they tell you that we have like temperatures that are going very, very low until the point of the karma line. And then suddenly we have these super high temperatures, degrees, going crazy and up to 2000 Celsius degrees. But all the measurements that the official equipment that can produce is below the karma line. And at least the pattern, the gradient, it's consistent with this. If we have temperatures like -100 degrees in 19 kilometers, maybe when you go up like this rocket that reach almost 120 kilometers, things are getting more cold than hot. So that is the first thing. The second thing is that when you go to the official things like, for example, the Einstein-Bose condensation, I don't know if you are aware of that kind of research that the science produced in the early 20th century, but all these behaviors in terms of, they are crazy trying to, let me go here, trying to understand what happened. The key is the lower temperatures. It's like the matter getting crazy, it's doing all these kind of strange things when it go almost to the 0 Kelvin degree. So I'm gonna play this video. It's only 2.5 minutes, if you allowed me, just for putting all the pieces on the table, and then you can everyone out there can make his own interpretation.
Solid.
You bet. Here, go for it.
It would not be a solid, or liquid, or gas. It was given a name almost as strange as its properties: a Bose-Einstein condensate. For the next 70 years, people could only dream about making such a condensate.
Matter can exist in various states. Atoms at high temperature always form gases. If you cool the gas, it becomes a liquid. If you cool the liquid, it becomes a solid. But
Of course, that is everybody knows that.
under certain circumstances, if you cool atoms far enough to extremely low temperatures, they undergo a very strange transformation. They undergo an identity crisis. So let me show you.
I like that word, density crisis. But if you are following the image that they produce to trying to, explain this, you're gonna have all these strange patterns. Of course, this is not from reality, but it's the idea that something really, really weird in terms of movement of these particles, quote unquote particles, are start to produce. So trying to keep this, keep that in mind.
What I mean by an identity crisis. When you go to low temperatures, the quantum mechanical properties of the atoms become important. These are very strange, very unfamiliar to us, but in fact, each one of these atoms starts to display wave-like properties. So instead of points like that, you have little wave packets like that moving around. It's really difficult for me to explain just why that is, but that's the way it is. Now, as you go to very low temperatures, the size of these packets gets longer and longer and longer. And then suddenly, if you get them cold enough, they start overlapping. And when they overlap, the system behaves not like individual particles, but particles which have lost their identity. They all think they're everywhere. This little wave packet over here can't tell whether it's this one or that one or that one or that one or that one, or it's there and it's there and it's there. They're all in one great big quantum state. They're all overlapping. They're all doing the same thing. And what they're doing, to a good approximation, is they're simply sitting at rest. This Bose-Einstein condensate is very difficult to imagine or to visualize. I could imagine what it's like to be an atom running around gaily, freely, bouncing into things, sometimes going fast, sometimes going slow. But on the Bose condensate, I'm everywhere at once. I've lost my identity. I don't know who I am anymore. I'm at rest, and all the other atoms around at rest, but they're not other atoms around. We're all just one great big quantum system. There's nothing else like that in physics, and certainly not in human experience. So just to think about,
yeah, maybe it's called ether, but
wonder and confusion.
The thing is that this state it's produced when you go really low temperature. So when you go up here, you have really low temperature, and when you start apply that with the superfluid behavior of the matter. Well, I don't know if okay, this is in Spanish, but when you apply that with superfluids, you have this strange behavior between gases that are really cooling down and start like lost. It not just the identity of the state, but they also produce no refraction. It's like zero index of refraction. It has no friction, which is really something that strange too. Let me just play this 1 minute clip.
There were more surprises ahead. In the 1930s, another strange phenomenon was observed at even lower temperatures. This rapidly evaporating liquid helium cools until at 2 degrees above absolute zero, a dramatic transformation takes place.
Suddenly, you see that the bubbling stops and that the surface of the liquid helium is completely still. The temperature is actually being lowered even further now, but nothing particular is happening. Well, this is really one of the great phenomenon in 20th century physics.
The liquid helium had turned into a superfluid, which displays some really odd properties.
Here I have a beaker with an unglazed ceramic bottom of ultrafine porosity.
Ordinarily, this container with tiny pores can hold liquid helium. But the moment the helium turns superfluid, it leaks through.
We call this kind of flow a superflow.
Superfluid helium can do things we might have believed impossible. It appears to defy gravity. A thin film can climb walls and escape its container. This is because a superfluid has zero viscosity. It can even produce a frictionless fountain, one that never stops flowing. Superfluidity and superconductivity were baffling concepts for scientists. New radical theories were needed to explain them.
So I just present this to have some pieces together, like we can now analyze what happened in the upper atmosphere. So I have here like a compilation, and this is where it's going to get what I tell you, that it's self-oriented. This is a sounding rocket launched by the German space agency called DLR in 2006, something like that. It's called Matthews 6. And paying attention to what happened to the sound and what happened to the orientation of the rocket. But before that, let me just clarify this. It's official that we have up in the upper atmosphere a gas, which is called the sulfur hexafluoride, which is a gas like has this property. It's colorless, odorless, non-toxic, non-flammable gas, so it not allow flame or burn of nothing like combustion related. Is present in octahedral molecular geometry, like some sort of dome, if you want to, in terms of molecular structure, and is 6 times more heavier than the regular air. It's more greenhouse effect is much bigger than the CO2, and it has a period of life of 3,200 years once get up in the atmosphere. And why it doesn't go down if it's more heavy than the air? Because the lower temperature doesn't allow it to go down. So the thing is that every time a volcano make eruptions, inject into that upper, this is for me are the pillars of the dome, if you want to see in some symbolic way, because anytime that a volcano here on Earth make eruptions, it injects to the upper atmosphere quintillions of tons of hexafluoro gas, among with the CO2, nitrogen gases, and things like that. But it's like these are like our pillars for the dome not going down or something like that, you know, because it produces all these components that you need to have this kind of state up in the atmosphere. So this is official data you can find on Wikipedia, on geological books or whatever. This is not some sort of imagination topic or something like that. So we have this kind of gas, we have this kind of temperature, we have this kind of behavior in terms of what happened to the matter in this lower temperature, especially on fluids, not just on regular solid matter. So what you're gonna see now is all these properties here on Earth, you know, like you can make it an image, because we have this gas which is 5 times more dense the air, is thermal insulator, non-flammable, reduce the sound frequency and not produce refractive index, and is colorless and odorless, so you don't gonna see nothing. It's gonna be like something completely invisible to the naked eye. So about the density, this is a really straightforward example. This aluminum foil is floating like being in some kind of fluid, and indeed that's what happened, because we have this container filled with hexafluoride gas. So in fact, you can take it and drop inside of the aluminum box, and the aluminum box starts going down, because it's the air in this state is not going to be strong enough to resist that weight. But like I told you before, this is just an example to see what happened in terms of density between this gas and the air that is around the room and the container. So here is the density part. Then you have the non-flammable or thermal insulator, because it uses in electrical industry to isolate big equipment of electricity before some kind of human enter there. And here you can see the pattern, how the candles start turning off in this pattern way, because the liquid or the gas is falling here, it's hitting the first candle and start to spread in this kind of circle pattern, shooting down the rest of the candle. So indeed, it not allow any kind of combustion there, but not only in terms of fire, but also in terms of electricity. When you put this device that produce electricity to give you some kind of shock electricity, when it's introduced inside the gas, it's turning off immediately. And when it's getting off again on the air, standard air, it's turning on. Then you have the sound frequency down. It's lower the frequency sound. So what I'm trying to, like I mentioned before, to present here is the conditions that this kind of environment produce. So when you have this rocket launch up in the atmosphere, you're going to have all these ingredients playing around the rocket. You have the sound that is going down because there's less air, of course. You start losing the flame, of course, because the rocket itself is getting off the fuel, but also for the conditions out there. Then they activate the yo-yo, the spin, to stabilize the rocket. And the inertia, of course, of the rocket is still keeping the rocket going up. So why is that fate produced? Well, that fate is produced by the O agency, because they say, now we're going to enter in 6 minutes of microgravity. But the strange thing is that now you can see the rocket, it's in this orientation, it's like a side orientation, and they're gonna show us where the rocket enter again in our atmosphere. And when I say that, I refer in like when it came from the 120 kilometers to maybe 100 kilometers up there. But you can see how the rocket is going to self-oriented again, like Earth sky type of orientation, and maybe it could be something more in terms of electricity. First of all, you're gonna see like dripping water coming up, came off, I don't know where, but you are going to see it. That is recovering the sound. Then you have this dripping water like in the superfluid state, and then it's self-oriented. And now that's orientation, correct?
It's a bit too loud. Either we cannot hear you.
The earth resistance.
Sorry. We could not hear you there. Sorry, we could not hear you because it was very loud, the video.
Okay, no, I say you have this kind of change orientation, and it's automatically. I mean, it's not for the rocket. It's not from the rocket. It's like something from the system itself.
It's like it's floating. It just all of a sudden became buoyant and floating on something.
Yeah, exactly. And then you're gonna have the sounds producing by the resistance with the air, but like some kind of boat sound. And the amazing thing is that I have here like a compilation of other rockets. You have the Go Fast, the NASA sounding rocket, Foxy rocket, the DLR Matthews 5, and the RockSat X 2012, and all produce the same sounds and the same behavior. Once they going from a really short gradient, because this is not happen, super slowly, this kind of transformations in terms of the orientation is a super gradient, super slowly. No, this is like a critical point. It is from here to up is this kind of lost identity state, and from this point down is everything correctly self-oriented. The sounds, it's again recovering. Everything is good again. So
start moving very fast as well, no?
start moving very fast.
Spinning.
They call this microgravity. I call this no identity state. And I mean, when you keep going, this is like illustration that I made is like you have like regular particles in the upper atmosphere, and then you enter to other state where things behave complete different to normal, because the lower temperatures, the conditions that happen up there. So what I'm trying to say is that for me, after seeing all these kind of things and connected with the sprite, that you have the limit also in the 100 kilometer. Remember, these gases are thermal insulator, so you don't gonna have sprite going up, because this kind of behavior and gases is not allow you, because you cannot produce electricity passing certain point in the upper atmosphere. So we have all the ingredients. This is my opinion and my hypothesis, to think that we have a barrier, but in a natural way. The intelligence that produced this world create this limit on the Antarctic, maybe with the low temperatures, and up in the sky with the same kind of technique, if you want to. And in fact, when you go to the ancient cultures, you're gonna have these kind of symbols that somebody said that is referring to our electrical magnetic nature. And you're gonna have also the pillars, this kind of pillars in Egypt and all that ancient culture that referring to the magnetic field of the earth. This is of course interpreted things that a lot of researchers drop out there. Then you have the connection. Sorry, I go really fast, I know that. Then you have the connection with our modern electricity gurus like Nikola Tesla. Then you have the Aurora Borealis symbology and all this kind of stuff. So for me, the barrier is some kind of natural barrier produced by gases in really lower temperature, and that's our dome.
Brilliant. Freaking brilliant, Iru. Wow.
You need to see our movie, Iru.
No, I have it downloaded. I have it right here.
You blew us away, but we went into a bit of this, but not like what you did. But wow,
awesome.
Yeah, I wish I had seen that earlier. But so, is it a negative charge up there? Are you saying, and the sprites are going up to it, just like gravity or whatever would come down? The positive reach the negative. Is that what?
I think that's relative. That's kind of relative. It is a charge potential difference, right? There's a difference of charge potential, whatever it is. So,
in whatever direction. Yeah,
wherever it needs to get to. Yeah.
But you have the electrical lightings, you have the comet, which in nature is more electrical than a piece of rock entering our atmosphere. And in fact, there is some experiments that they say that if you have enough electrical discharge in our air, you can produce like tiny metal balls, tiny rocks balls from electricity. I don't know if that's true or not, but I mean, for me, every time that you look up there, you are seeing electrical fields, and everything is behave under electrical conditions. It's not rocky space junk that entering in our atmosphere. And then you have this limit, and this is official data that has 90 kilometers. Everything is in that point between 90 kilometers and 100 kilometers is all the magic. That is 10 kilometers gradient that produce all the magic,
Jeremy?
No, I was just saying, which is incredible, because that's the line. Right?
Exactly.
Yep. Yeah, so much happens at 63 miles. It's unbelievable.
Boy, that's where the comets burn out when they get down to 30 to 60, or the meteors, the flash, they equalize down here.
Which tells you that they are not right. They're not actually physical things. They're charge differentials that are equalizing.
Yeah, exactly. Wow, that was crazy. That was
Then you have the moon behavior. With magnetic and electricity, you can explain why we see only one phase, for example, on the moon. If you want to, bring some ideas, because of course it's following the magnetic field, so you're always gonna have one phase pointing into the center of some kind of magnetic machine. Then you have this other thing. The last thing that I'm going to present is this, and again, what must be keep in mind is that all these phenomena happen only in lower temperature. So remember that those gases at that conditions is frictionless. It don't produce friction. So maybe it's that why the planets are not falling down into the Earth and never stopped circling.
Right. Well, that was actually one of the things that Newton, when he postulated the vacuum of space, that was the idea, right? Because if these
must
things
be
are
something
moving,
that exactly
it's frictionless. It had to be frictionless,
Exactly,
but he thought it would be the vacuum and not. He never thought there would be superfluids.
Yeah, but remember that at that time, these Kabbalistic guys, they don't even play with the electricity.
Right.
And 200 years later, 200 years later, electricity came to Occident, and they maybe want to
the West,
cut off his heads, because they start thinking, oh man, it's not gravity, it's this kind of thing, it's electricity. What we're going to do?
They have to keep what they built up. They have to keep spitting that. They can't dare change their entire foundations.
This is
or just ease into it. Like I was just showing you with the electric moon now, and they're starting to ease into. Oh, well, maybe there are electrical fields up there that are doing something. They cannot go against. Right, they cannot go against the progression of science, real science, for long. Right.
Yeah.
Exactly. Just why. Exactly why they have recently come out and said that the moon is actually in our atmosphere.
Yes,
right, that's the other one.
Yeah, that's also. And in fact, remember that if our moon is in our atmosphere, it's very, very for us. I mean, it's very nice, because we can explain the electrical behavior and nature from the craters. Because if we have some sort of remember, for me the moon is not so far away, and when you go to the electrical universe, they can produce and recreate all the craters that we see in the moon, and in fact, something that caught my attention was the news about when some we have a lot of observatories down on Earth looking at and recording 24 hours per day the moon, and sometimes they film these things called meteor impact. But when you look at those supposedly meteor impact, it's more like electrical discharge than an actual rock hitting the moon. And I'm going to show you right away. Let me just finish to play this. This is all electrical conditions to form rivers, mountains, craters, valleys, and so on and so forth. But this is an official lunar impact, for example. And when you look at these kind of things, it's super fast, of course, very tiny, super glowy, and you're gonna tell me that was a rock? And NASA even so they are worried about the meteor that it's coming to our Earth, but they are not capable to warning us about the rock that hit the moon. Mm-hmm. What kind of equipment these guys have?
Make believe.
Wow.
So this is from the University of Huelva, which is a university in Spain. And when you see this is an electrical discharge for me. I mean, it's appear from nothing. It's something that's glowy, doesn't hit any dust. It's like don't kind of disturb nothing on the moon and appear from nothing. You don't see a trail coming. You don't see nothing. It's just like some kind of electrical thing and done. It's like this electrical relationship maybe between the the sun, the moon, the other things up there. We don't know. I mean, that is too much for everyone, I believe. And this is the last thing. It's a 2 video clip, but this is I presented this like an idea of orbiting mechanics, if you want to see in that way. And I know everyone out there know about this technique, but look what the guy explained.
The phenomena you saw here for a brief moment is called quantum levitation and quantum locking. And the object that was levitating here is called a superconductor. Superconductivity is a quantum state of the matter.
So we have superconductivity, superfluid, super this, Superman, super. It's up there. Is everything is super, you know.
Mm-hmm. And it occurs only below a certain critical.
And this is the key. Everything, all these phenomena happen under certain critical lower temperature. It's when cooled below a critical blah blah blah. So everything happened on lower temperature. And what we have in Antarctica, lower temperature.
So a superconductor is defined by two properties. The first is zero electrical resistance, and the second is the expulsion of magnetic field from the interior of the superconductor. Inside a superconductor, there are no collisions, so there is no energy dissipation.
Bing bang.
It's quite remarkable. Think about it. In classical physics, there is always some friction, some energy loss, but not here, because it is a quantum effect. But that's not all, because superconductors don't like magnetic fields. The combination of both effects, the expulsion of magnetic field and zero electrical resistance, is exactly a superconductor. And let me show you how this works. I have here a superconductor, and when I place it on top of a regular magnet, it just stays locked in midair. Now, this is not just levitation, it's not just repulsion. I can rearrange the fluxons and it will be locked in this new configuration, like this, or move it slightly to the right or to the left. Now, of course, I can turn it upside down and it will remain locked. For example, I can make a large circular rail here. It moves freely. And again, that's not all. I can adjust its position like this and rotate, and it freely moves in this new position. And I can even try a new thing. And hopefully, if I did it correctly, it stays suspended. You see, it's quantum locking, not levitation.
So the amazing thing for me is that we have these two inaccessible territories in our Earth, which are the most coldest place on Earth, which is the North Pole and the South Pole, or Antarctica and the center for us as flat earthers. So we have all, for me, you know, for closing the topic, but for me, we have all the conditions to at least trying to explain things more in this way than in the gravitational Copernicus, Newton, Kabbalistic Jesuit ways.
Yeah,
Absolutely.
well, you can see in the beginning video you played where, you know, he's in the Jesuit particle science and he's like, we can't understand this and explain it because he's starting to understand waves and magnetism, you know, and electricity instead of particles.
And then you have the explanation of
it. Well, that's why they can't figure it out, because they've taught the wrong idea of what reality is.
One of the things that they did, as Bob has explained as well, and they can get into that, is how they adapted the equations for electromagnetism.
Yeah.
Right. usurp them essentially to make it work.
And then you have all the antiquities culture talking about the electrical field that we have on Earth. And every ancient culture, they know, and they represent as an onion magnetic field type. This is the Shri representation made by a plastic and some neon light. But this is in our real life. This is the same thing. Here you have from Tesla, Apple video the toroidal field producing by magnetic field. So we have all these in our world. You have this Shri Chantra that so many people see on the walls in some houses or museums. This is a 2D representation of this. And when you see this 3D representation of our magnetic dome, is this? Is this? It's produced by electricity and magnetism, and then you can go really inside of the Santos Bonacci school, and he can explain very well in terms of the symbology behind the torus field, the torus, the rotor, which is referring to the same thing: motor, rotor, torus, dome, whatever. It's all over the place. So
they wrap it on the ball as well.
Yep.
Yeah, exactly. We have these 4 magnetics points in our Earth. So you have all these. The ingredient is out there.
Is that the 4 pillars of the Earth?
Yeah, exactly.
Yes, the 4 corners.
The 4 pillars. The corners, yeah.
Yes.
That's that.
Very much so. And we've covered that before, talking about that as well. And yeah, I absolutely believe that's exactly what we're talking about here. Very interesting. Great presentation here, as always.
Great.
So, guys,
and the last thing is I'm not going to present, but remember when the official scientists go to produce stars, they produce stars inside of liquid. So you need a medium, you need some kind of field, and then they use sound to produce a star, and then the star itself is just like a tiny bubble of energy trapped inside of some sort of medium. So you need some kind of medium up there. The problem is that we see to the sky, because this under lower temperature, we are not capable to see any kind of index of refraction or something that tell us, well, we are looking up there are gases in this state, because they lose all the regular properties under the lower temperature. So, finish.
Very good.
Yeah,
Okay.
absolutely. And I know we're dragging on, guys. We're probably getting long, but
yeah, we're close to 4 hours.
Film too. Yeah, sorry, but Iru, in our film, you'll watch it. But we got into nitrogen, which is most of our atmosphere. And when it has a dielectric constant, but when you bring it down to a gas or a liquid form, that's where your nitroglycerin, this thing becomes highly electric. So this is fascinating because there's something to this. You're right.
Yep.
It is this.
We clearly need to do another show and continue this, right?
Well, this is bad. Yeah, I was going to say we should have done this at the beginning. We could go on, but